Good morning everyone. Today we learn another method to solve the game. This is the method of oddment for solving 3x3 games. We can use this method which does not have any saddle point and its dimension is 3x3. Then we can apply this method. Yes, definitely you can apply the dominance rule and dominate the rows and column and convert the matrix into 2x2 and apply any other method like analytical method and algebraic method. But here we can see that the any row or any column does not dominated by each other. Then what we have to do? So at that time we have to use the method of oddment. So here our problem is solving by method of oddments. So first here we check that the game has any saddle point or not. So here we can see that calculate row minimum and column maximum and then minimax point. So our minimax point is a -3 and maximum point is a 3. They both are not equal. That is why we use the method of oddment to solve the game. So the step 1 in the method of oddments is first we have to calculate the row differences as well as column differences. So in the row differences here first we have to calculate first difference by subtracting second row from the first row and second difference by subtracting third row from the second row. So if we subtract second row from the first row, then we get this 6 minus 4 minus 2, and when we subtract third row from the second row we get 1 6 and minus 4. In the same way we can calculate the column differences 4 minus 6 minus 1 2 4 minus 6. Here also I write it down that subtract each column from the first column to its left. That means you always have to follow this way to find the difference. In the same way, subtract each row from the row to its above. Now we move ahead to step 2. Calculate the oddments for the A's all 3 strategies and B's all 3 strategies. So you also think about that what is the oddments, and this method is also known as the matrix method. So the oddments are also similar like minors of the matrix. They are not exactly minors but similar like that, and we have to find the determinant of that minors. So here we can see that the oddment for the A's first strategy. So how can find this oddment? So here if we want to find the A's first strategy is oddment, then we have to look after the this difference and we have to omit the A's first strategies from that. Then we have remaining 4 terms in this column difference table. So these 4 terms are -6, 4, -1 and -6. So these 4 terms are is our oddment and we have to find the determinant for this oddment. So here we can see that the oddment for A's first strategy is -6, 4, -1 and -6 from here. Now we also calculate oddment for the A's second strategies in the similar way. So while calculating the oddment for the second strategy, we have to omit the whole second row with the column differences. So remaining 4 terms in the difference table are 4, 2, -1 and -6, and our oddment is also 4, 2, -1 and -6. In the same way, you can calculate the oddment for B strategies like if we want to calculate the oddment for B's first strategy, then we have to omit this whole first column and take these 4 elements as a oddment. So -4, -2, 6, -4. So here we can see that -4, -2, 6, -4 and find the determinant of it, that is a 28. So in similar way, we can find all 6 oddments for A's 3 strategies and for B's 3 strategies. Now we move ahead to step 3. Now, in the step 3, we have to verify the sums of the oddments of player A and player B. Here I underline the statement, they must be the same. That means the sum of player A's oddments and player B's oddments must be same. Only then you can move further. Otherwise, you fail to solve the game by the method of oddment or matrix method. So here, if the sums are equal, that means both players use their pure strategies. Otherwise, if some are not equal, then you cannot solve this game by this method, because if the sum are different, then it proves that they used mixed strategies while playing game. And this method is only used when they play game with their pure strategies. That is why the sum must be equal. Now we move ahead to step 4. While verifying the sums, neglecting the sign as shown below. That means your determinant terms are this, but you have to neglect this minus sign and you take the only value of that determinant. That means 40, 22, 28, 28, 22 and 40. The sum is column is also 90 and the sum of this row is also 90. That means here condition is fulfilled. The sum of player A's oddments and player B's oddments are same. Here I also mark the remark. You can read it carefully and note it down. Now we move ahead to step 4. How to solve the probabilities of player A's strategies and player B's strategies. So we simply can divide this oddment by the total and find the probabilities of strategies. So 40 by 90 is the probability of player A's first strategy. 22 by 90 is the probability of player A's second strategy, and 28 by 90 is the probability of player A's third strategy. In the same way, you can calculate the probabilities of player B's all three strategies divided by the total sum 90. Now the last step, how we can find the value of game. So we can find the value of game by 6 ways. But you can get the same answer by these all 6 ways. You can calculate this value of game by multiplying the player A's oddments, multiply with all columns. You can multiply this oddment with these all 3 columns and divide it by 90. Then you can get the value of game. In the similar way, you can multiply these oddments, these 3 oddments with any row, any of these 3 rows and divide it by 90. Then you can get the value of game. You can see that you get the same answer by all 6 ways. I hope you understand the method and thank you for watching.